problem from the SAT chemistry subject test wants us to answer 3 questions about this potential energy diagram. The first question asks, what is the activation energy of the reverse reaction? So starting from the ending point, or the starting point of the reverse reaction, and going up to the transition state, we see that this is equal to the energy change marked as E. Next, we want to know the enthalpy change of the forward reaction. So going from the starting point of the forward reaction to the end point, we see that this energy difference is marked as B. Finally, we're asked what is representing the energy of the activated complex. So the activated complex I've marked in blue, or that is the height of the energy complex. So going from 0 up to the total energy, we see that that is marked by A. We're given a question from the SAT chemistry subject test, which gives us a value for pH and wants us to find the hydroxide ion concentration. Let's recall that pH plus pOH equals 14. So since we're given pH, we can calculate the pOH by subtracting 5 from 14 to get 9. So our pOH is 9, and then to find the OH minus concentration, we'll take 10 to the negative pOH, which will be 10 to the negative 9th. So our final answer is B, 1 times 10 to the negative 9th molar. This question comes from the SAT chemistry subject test. We're given a reaction above and asked what NH4 plus acts as, and we're given 5 options. So first we need to identify what type of reaction we have, and we can see we have an acid-base reaction. So the ammonia, of course, acts as a base, and the carbonic acid acts as an acid. Once we get to the other side of the reaction, we have our conjugate base and conjugate acid. So in this case, going from the base, we have our conjugate acid, and going from the acid, we have our conjugate base. So NH4 plus will act as an acid. This question comes from the SAT chemistry subject test. We're given the above phase diagram and this information. Substance Z is at 0.5 atmospheres and 200 Kelvin. If the pressure on substance Z is steadily increased and its temperature is kept constant, what phase change will eventually occur? We can go ahead and pencil in to see what our starting point is of approximately 0.5 atmospheres of pressure and 200 Kelvin temperature. And so we can mark that in blue, and we know the temperature is kept constant and the pressure is steadily increased, which would bring us in this direction on the diagram, going from the gas phase to the liquid phase. And given our options, if we're considering what phase change occurs, it will be A, condensation. The following questions come from an SAT chemistry subject test and require you to match a piece of lab equipment with an experimental situation. The first question says it may be used in combination with a calorimeter to compare the specific heats of 2 substances. In order to measure temperature changes, you will need a thermometer. The second question says that the equipment is used to measure the volume of a solid by water displacement. In this case, you may be measuring density, in which you will be using E, a graduated cylinder. Next, it is useful for adding small quantities of acid into a base. This should make you think of a titration, in which you will use D, a burette. Finally, we need a piece of equipment to complete the circuit of an electrochemical cell. In order to replenish the electrolytes in your solution, you will need C, a salt bridge. This question comes from the SAT chemistry subject test. We're asked, which species has the ground state electron configuration 1s2, 2s2, 2p6, 3s2, 3p6? In this video, I'm going to teach you how to use the periodic table, which you would be given on an exam like this, to determine electron configurations relatively quickly. So just looking at the periodic table, the leftmost 2 columns represent the S block. The right-hand side of the periodic table, excluding helium, are the P block. The transition metals make up the D block, and then down at the bottom, we have the F block. So let's go through and map out this electron configuration. So we're given 1s2, which is hydrogen and helium, 2s2, 2p6, 3s2, and 3p6. So the element we should be looking at is argon, but this is not an option we're given. So let's go through each of these options to see which would be plausible. So for A, sulfide ion, S2-, we are adding 2 electrons to sulfur. So sulfur is located in this column, but we're adding 2 electrons. So sulfur is actually chemically equivalent to argon in this ionic state. So let's remember sulfide ion as a possible option. Now let's go through and look at bromine. So bromine, you're adding a single electron for the ion. So we're going from this column, adding an electron. So bromine would actually be chemically equivalent to krypton. So bromide ion is not an option. And we know it's not neon because that would be ending at 2p6, so we can cross that option out. And then for chromium's way over here in the transition metals. So no matter what it is as an ion, it will not be chemically equivalent in this case. So we can go ahead and cross out the chromium ion. Next we have potassium atom. So this is actually in the next energy level. So that would be 4s1. So we know potassium atom is not going to work. So our first guess here is correct. We have A, sulfide ion S2- as the species for this ground state electron configuration. And of course, when you're doing a standardized test, you're going to kind of want to move as quickly as possible. So maybe you would just go, I'm confident with sulfide ion because I know that that is correct. You can select that answer and move forward. But here we have proven that it is indeed sulfide ion and there's no guessing required. This question comes from the SAT chemistry subject test and asks, which of the following atoms has the largest second ionization energy? So if we think about what ionization energy means, it's the amount of energy it takes to remove an electron from an atom. So having the largest second ionization energy probably means we're looking for an element in the first column of the periodic table. And why is this? So for these atoms, when they lose a single electron, that puts them back over here into this column. So we'll call that the first ionization energy. And then it becomes chemically equivalent to a noble gas. And that is the state they want to be in. So if you think about H+, Li+, Na+, these are the states that they prefer to be in as an ion. But then if they lost another electron through the second ionization energy, then it would be very difficult to remove an electron from a noble gas because they're very stable and it would just take more energy. So atoms in the first column of the periodic table have a lower first ionization energy and a much higher second ionization energy. So let's go through our options here to see what possibility we have. So for silicon, it's not in that column of the periodic table that we're looking for, and neither is calcium or iron or chlorine. But sodium is in fact in that first column of the periodic table, and that's what we want to see. So our final answer is E, sodium. This question from the SAT chemistry subject test asks, how many electrons does a 37 chlorine ion with a charge of -1 contain? So looking at the periodic table, we see that chlorine is element 17. So since it's element 17, that means we have 17 protons and 17 electrons in a normal chlorine atom. They're kind of throwing you for a loop here with the 37 because that's the isotope symbol, meaning there's a different number of neutrons, but we're only concerned with the number of electrons here. And so normally we'd have 17 electrons, but with a charge of -1, we're going to add 1 electron, and that will give us 18 total electrons. So our final answer is C. These are some matching questions from the SAT chemistry subject test. The first question says that the atom or ion has 7 valence electrons. So for this, we're going to want to look at the column of the periodic table involving halogens and see if we have any here. So if we look at our options, we see that fluorine is an option for C, so that's the answer to number 10. Next, we want to know which one has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p1. So we'll just go through 1s2, 2s2, 2p6, 3s2, 3p1, and we see that it's aluminum. So our answer to 11 is B. Next, we want to know which has the same electron configuration as a neon atom. So for neon, we see that it's going to be an ion, and so we say our options are Br minus or Na plus. So for Br minus, we see that would be chemically equivalent to krypton. And then the sodium ion, we're losing an electron, and that would become chemically equivalent to neon. So number 12 is A. And then our final question is that it's a valence, or has valence electrons in d orbitals. So that means it's our outermost shell. And so although Br minus would have d electrons in the electron configuration, titanium is a transition metal and would have valence electrons in the d orbital. So our answer would be D. These questions from the SAT chemistry subject test require us to match a measurement with its unit. So going through our options, we know that molarity has units of moles per liter. Molality has units of moles per kilogram of solvent. Mole fraction doesn't have any units because as a fraction, we would cancel out the units. Density is usually measured in grams per milliliter or grams per liter. And partial pressure can be measured in any unit for pressure, like atmospheres. So going through, our first question asks exactly that, units of atmospheres or millimeters mercury. So we know that is E, partial pressure. Our next asks units of moles per kilogram, which we said was B, molality. Next, we have mass per unit volume, which is D, density. And finally, we have the quantity used in the calculation of boiling point elevation, which we know is mole fraction. Here we have a standardized test question asking what is the percent by mass of silicon in a sample of silicon dioxide? So we're going to need to know the mass of silicon, which from the periodic table is 28.09 grams per mole. And the mass of silicon dioxide would just be the 28.09 plus 2 times 16, which is the molar mass of oxygen. And adding that together, we get 60.09 grams per mole. So to find the percent of silicon, we need to divide 28.09 by the 60.09. You can probably do this mental math, but we get 46.7%, which is approximately 47%. So our final answer is C. For this problem, we're looking at changes to an ideal gas in terms of pressure and temperature. So if everything else is held constant, we can just do the calculation of P1 over T1 equals P2 over T2. So we know we're starting with a pressure of 6 atmospheres, and we know that in the ideal gas law, our temperature needs to be in Kelvin. So we can do this conversion relatively easily just by adding 273 to each of the temperatures. And for T1, we'll get 300 Kelvin. And then for T2, we get 200 Kelvin. So now we just need to know what is P2. And if we cross multiply here, the 6 times 200 gives us 1200, divided by 300 is 4 ATM, which is C.